And let's now look at another example. So let's spend some time reading the problem itself here. So here we are given that if sine of alpha equals 0.677. So alpha, here's the angle, and we have sine of alpha is given being in decimal 0.677. So that's one highlighted information. And cosine of beta. So here beta is another angle. So these two are, so we got sine of alpha, and here we have cosine, but cosine on beta. Alpha and beta are two different angles. And then once again, back to what I was in the middle of, then cosine of beta is given to be 0.724. So we have two given values, two trig values given right here. And a further information here saying with both angles terminal rays being in quadrant 1. So let me quickly swing to my writing board and quickly describe what it means right here. Quadrant 1. So we've learned a little while ago that quadrant 1 means on the unit circle here, it's that positive x and positive y quadrant. This is quadrant 1. And so the wording of the problem says the angles terminal rays, both of those are in Q1. So what it means here is that we can imagine that maybe alpha is this terminal ray right here, and that's we can call alpha, and beta is a different angle, so we can draw beta as kind of like another angle here. So this is beta right here, so that gives me beta. Okay, so that's what it means by both of the angles terminal rays are in quadrant 1, and this is again Q1. And so now back to the problem itself right here. We are looking for part A. Find the values of sine of A plus B. So now let's one by one use this given information and find these two required problems right here. So really in one example, but we have two little problems. So I'm now going to head out for part A right here. All right, so now this is how we can use our given information. So we know that we have sine of some angle alpha to be 0.677. That means, and notice that the other value we have is cosine of beta. So these are just two different angles, so their two sine and cosine values are not related. I have to emphasize that these two values are not related. They are just simply two given information, two pieces of given information. So 0.724 here. Okay, and so now that we have learned with the Pythagorean identity that sine square of any angle, so sine square of alpha plus cosine square of the same angle alpha. So now I'm talking about the same angle with alpha over here. So not cosine of beta. This is cosine of alpha. So sine square of alpha plus cosine square of alpha. Pythagorean identity says this should always be 1 regardless of whichever value our angle alpha is. In radians or in degrees, it should all going to obey this identity. And so now right from this famous Pythagorean identity right here, then we can start substituting in our given sine of alpha value, 0.677 here, right into this equation. So now in the next step, I'm looking at 0.677. After substituting in for sine of theta, sine of alpha, then we're looking at 0.677 square in quantity square plus cosine square of alpha, and to equal 1. And now at this point I have to admit I am on my way to solve for the cosine of alpha value, because what's missing in this, what's missing here is that we already had sine of alpha, but we don't know cosine of alpha, the other, sort of like in the way how I see it, the other partner of the same angle. So sine is one value and cosine is the other partner on the same angle here, and we're on our way to find that. So right now cosine of beta is not useful for our work yet, but now we can proceed to solve for cosine of alpha. I am now going to subtract, and anyone viewing my video here can go ahead and independently give it a try as well. So subtracting 0.677 square on both sides, okay, we will end up with cosine square of alpha to equal 1 subtract 0.6772. And then when this problem is when you're actually seeing a problem like this among your different assignments, then be aware about the rounding requirements here. So here I'm just showing a generality of the problem, but then when it comes down to the rounding, make sure, especially if you're doing an online assignment, then make sure you have to watch closely for your rounding requirements of those online assignment problems. But now I am ready to calculate my actual cosine of alpha, because right now I have only found cosine square of alpha, and that's all equal all this here. But now finding cosine of alpha means we have to take square root of both sides. So taking square root of both sides here means we must have plus and minus square root of 1 minus 0.677 square inside of the square root. And now at this point we must make a choice, a decision about which one, the positive or the negative square root expression here that we're going to be using for our problem. And so recall with that piece of information we have seen in the computer screen for here, then see both angles terminal rays are in quadrant 1. That means right now we can simply understand that, we can just simply draw an understanding that our alpha is in quadrant 1. That's one simplest way of putting it. Our angle alpha is in quadrant 1. And so with that valuable information right here, then recall that being in quadrant 1 means well, alpha is being in quadrant 1. Being quadrant 1 means a positive, sine value and also positive cosine value. So I purposely emphasize that because that is useful right here into our problem. That now means we must decide to take cosine alpha here to be the positive square root of this expression. So now I'm looking at positive 1 minus 0.677 all squared like that. And so now I'm ready for doing a final calculation. So final calculation now shows that our answer in here in my lecture, in my video here, I'm going to be using about 5 decimals. 0.73598. All right. So that is our cosine alpha value. And now on the other hand, we already had cosine of beta equals 0.724. Similar work that we have done for our cosine of alpha. Now let me make a note here. We already had cosine of alpha to be 0.73598. And now I am going to find the other partner of cosine of beta. So on this angle beta right here, the other partner is going to be sine of beta. Okay, and that's what I'm about to find out. And so again, doesn't matter what angle we're at, but Pythagorean identity will always hold. Sine square of beta plus cosine square of beta must equal 1. And in this case, we already had the value for cosine of beta to be 0.724 here. Now I have my right to substitute it in. So sine squared of beta remains the same here in our equation. But for cosine squared of beta, now I can write that as 0.724 all square and to equal 1. Okay. And so very similar to the earlier work we have seen when we were solving for cosine of alpha. And here I'm going to solve for sine of beta. But before that, we must solve for sine square of beta first. And so we can get that by subtracting 0.724 square from both sides. And that gives me a final equation to be sine square of beta to equal 1 minus 0.724 all square. And so now to find sine of beta, the next step here is to take the square root of both sides. The square root on both sides right here. But recall again, anytime we're taking square root on both sides of an equation, the right hand side will give us plus and minus square root expression. So here inside of that square root, we're looking at 1 minus 0.724 all square. All right. And then once again, we need to decide whether we're going to be going with the positive square root expression or a negative square root expression. So that decision-making line is here. Once again, we have learned through the wording of the problem that, again, with both angles terminal raised or in quadrant 1, that means, again, we can imagine that here's our unit circle. Quadrant 1 is here. And according to what I've shown on the computer screen, then beta is also in Q1. So beta in Q1 means we can think about some angle right there, and that's beta. Okay, so being in Q1 in quadrant 1 means a positive sine and also positive cosine. But this time we primarily are going to focus on positive sine beta. And so that means our sine of beta here has to be a positive value. So we're going to take the positive square root. So that means in the next step, sine of beta equals a positive square root of 1 minus now 0.724 all squared. All right. And again, calculation shows that we have 0.6898. Now, so even though I wanted to round to 5 decimals, as I have explained earlier, but in this case right here, and the calculation came out after the lengthy calculation, calculating decimals, then rounding to 5 decimal places forces us down to 6898 only. And so now we have our sine beta to be 0.6898. So now, after we have successfully found all the missing partners, so we had our sine of alpha given to be 0.677, and we found a missing partner for our alpha to be cosine of alpha equals 0.73598. We had cosine of beta given in our problem being 0.724, and we have just now found a missing partner. So sine of beta equals 0.6898. And so now, really at this point, we are ready to get into part A of the example. It took a little while to get around, but now we got into part A of the example. Part A is looking for a sine of alpha plus beta. Sine of alpha plus beta. So that means this is sine of a sum. So sine of alpha plus beta, first thing, we can rewrite this as, we can develop this out as sine of alpha times cosine of beta according to the sum identity plus sine of beta times cosine of alpha. And now the entire usefulness of having all of these missing partners found before I get into part A and part B is that now we have all of these values ready. So sine of alpha was given. Cosine of beta was given. So these are 0.677 and 0.724. And of course, those two are in product. And now, so 0.677 times 0.724, and we're going to add. See, the usefulness of finding all the missing partners is that now we can bring them into our current equation. So sine of beta, we've just now found to be 0.6898. So 0.6898. And we're going to multiply that with the other value to be, and that value is to be 0.73598. And now overall answer came out to be 0.99783. Okay, and here again, in this video lesson, I'm using 5 decimal places for the final answers, for the final answer and maybe the next final answer. But again, if any of you viewing this video, seeing this problem being given in your either online assignments or in any of your assignments given by your instructor, then make sure you look for or watch for rounding requirements in each of your assignments. Now let's look at part B here. So part B, it seems like another work waiting ahead, but let me tell you, it's not going to be as much work because we have had a lot done here. So now in part B, we are finding sine of alpha minus beta, sine of a difference. So back on my writing board, I already erased and make space for part B to be ready, but I never erased this valuable information that we have found here, because now part B, once we have found all the missing partners of alpha and beta over here, then all right, so sine of alpha minus beta, sine of a difference, according to our difference identity, sine of a difference identity, then this is going to be equal to sine of alpha times cosine of beta, and subtract sine of beta times cosine of alpha. And now, once again, once we have written out the identity, then everything is ready for us here. Sine of alpha is 0.677. Cosine of beta is 0.724. And so 0.677 times 0.724 minus, now sine of beta can be substituted by 0.6898 here. So 0.6898 substituted for sine of beta. And then here the next value, cosine of alpha, we can make use of that value right there. So 0.73598 is substituted in for cosine of alpha. And so now another calculation value is to come out. All right, so my final answer came out to be, and in 5 decimal places again, 0.017531. All right, and again, anyone viewing this video, this is only a for anyone viewing this video, this is only a generality of how we get the problem done. But again, when you actually apply this into your assignment here, then watch out for rounding convention, rounding requirements in each of your assignments that has problem like this one. And so before we are completely done with this kind of problem here, then I would like to point out a generality in case any of you will see a similar kind of problem somewhere here and there among your given assignments. But the whole generality about this problem is that we are given some two values. In this problem here, I have sine and cosine, but maybe in your problem you can have both sine of alpha and sine of beta. But the point here, the main point, the main generality here is that you will be given the sine, either sine or cosine value, but on two different angles. That's how the problem is being started. That's how I see about this problem. It started out giving you two values, two trig values, but on different angles. So let me undo all the highlighting here and only focus on the part we need. So we're looking at sine of alpha. Okay, so the angle here is alpha. Here in my problem, I had cosine of beta. Okay, so primarily as a generality, I would like to point out we're having two given trig values, but came out from two different angles. Okay, and so in that way, then you must ensure before you find your actual problem. Then here what I did, I had given alpha, that's what I had, given alpha, sine of alpha and cosine of some beta. So the next generality I would like to point out here is that you need to find the missing partners. So if you already had your sine of alpha, then you're going to need to find your cosine of alpha. That's the missing partner. So allow me to write in red ink here. You need to find cosine of alpha because that's the missing partner relative or in respect to that angle alpha. And if you already had cosine of beta given, or in your problem it could be sine of beta given, but find the missing partner. So in my case here, my missing partner is sine of beta, and I'm using that term, the missing partner, in a sense that for any angle we always have two values, sine and cosine. So angle alpha has two values, sine and cosine, and for the angle beta we have two values, sine and cosine. And so these are always a pair, and that's why I call them the partners. And so you're going to have to find the missing partners. And once you've found the missing partners, then your problem can ask you to find cosine of alpha plus beta, or your problem can ask you to find cosine of alpha minus beta, or your problem can ask you, just like how we've done in this problem, find sine of alpha plus beta. Whichever case that can happen, or sine of alpha minus beta. But once we have found all these missing partners and have had all of these four important information, then you can just use the sum or difference identities to expand out the form, the identity, and then substitute in these values, and that's how you're going to land into the final answer.